In this video, I'm going to introduce you to the ratio test. So suppose you have a sequence looking something like this. So as n, take the limit as n tends to infinity. So we don't really care what happens around here. We only care what happens when n heads towards infinity. So really far to the right. Let's say your current term is an, and then your next term is an plus 1. So the ratio test is saying get your next term. So get your next term here, divided by your current term, divided by your current term. So if the whole thing here if the whole thing here is less than 1, if it's less than 1, then you can conclude that the original series will converge. So suppose you have, looking at this, suppose you have a series looking something like this. So this is your current term, an, and then your next one is an plus 1. So the ratio test is saying get your next term, so get this term, divided by your current term, divided by this one here, and then if the whole thing is greater than 1, then you can conclude that the original series will diverge. If it equals 1, then it's inconclusive, and you have to do more tests. So let's try and have an understanding of what's going on. Let's look at this thing. So let's try and understand what's going on. So suppose you have a sequence looking something like this. So remember, we are concerned about the limit as n tends towards infinity. So we don't care what happens around here. So just imagine this is the very far right of the graph. So as n tends to infinity. So imagine the graph has been cut somewhere along here, and this here is really far to the right. So it's saying get the ratio test is saying get your next term, divided by your current one, an. So you can imagine this as being, well, your next term here is 3, so it's going to be 3 divided by your current one, which is, in this example, is 5. So here you can see that this is less than 1. So you can conclude that that this series will converge. So let's have a look at another example. So suppose you have a series looking something like this, and then it goes up. So it's saying get your next term. Hang on. It's saying get your next term, which is this thing here, which in our case is 7, divided by the current one, which in our example is 5. So you can see that this thing here is bigger than 1. Well, you can see looking at the graph, you should have a gut instinct that is going to diverge. So let me give you another example. Hang on. So remember, an plus 1 divided by an, it doesn't tell you the limit, even though you're taking the limit here. It doesn't tell you the limit. It only tells you that the graph is flattening out. So for example, hang on. So for example, this here. It only tells you that the graph is flattening out. When you get when you get an plus 1 divided by an, and the limit of this thing here equals 1, it only tells you that the graph is flattening out. It doesn't tell you what the limit is. Well, if you look at this here, the limit of an here will be 3. But when you look at an plus 1 divided by this, when you get the next term divided by your current term, if it's around 1, then you know it's going to flatten out. You see, all this thing here is telling you is that it's flattening out. It's not this here. The limit of this is not 3. The limit of this ratio here is not 3. The limit of this ratio is 1. It's just telling you, by you being equal to 1, it's just telling you that the graph is flattening out. So let's go back to this. So if you look at this example, if you look at this harmonic series, it will look something like this. When you get an plus 1, divided by an, all that this is telling you is that as n tends to infinity, it will flatten out. The limit is not the limit of an is actually 0. It's heading towards 0. But when you look at this, all this is telling you is that the graph is flattening out. It's flattening out. That's all that is telling you. Well, as it turns out, this equals 1. It means that it's inconclusive. So you've got to do more tests. So hang on, more examples. So as I said earlier, in this example, an plus 1 divided by an, because it equals 1, all that it's telling you is that it's flattening out. It doesn't, yeah, it's flattening out. That's all that it's telling you. So looking at this here, you see this here actually equals 1. All that it's telling you is that it's flattening out. So here we are looking at an example of the series 1 over n squared. Here it's flattening out. So this is inconclusive. It equals 1. But because we've done this many times, we know that this actually converge. But the limit of the ratio here, it equals 1. Looking at this example earlier, looking at this example of this harmonic series here, it also equals 1. But because we've done this before, it actually diverged. But when you're doing the ratio test, this here is inconclusive because it's 1. So this, for the harmonic series, is actually inconclusive with the ratio test. So 1 over n squared is actually, with the ratio test, it's inconclusive. So hang on, let me, I will continue in the next video. We need to take care of the negative case. I will carry on in the next video.